So, hello friends. Uh, Today we will talk about or discuss some questions about the on previous video I put on my that is my first YouTube video. That is you can see that video, and now in this video we will discuss about the questions uh, particularly on wave functions and some on particle in a box. So let's start with our first question. So in my first question, I have given the commutator. I have to solve commutator x square comma p square. Here x is the position and p is the momentum. So all of you know that the commutator is given by sorry a operator comma b operator ab minus pa. So it is given by this. So here we will solve like I have given it here. So here is x square comma p square. Now what you have to do in this, like you have to it is x square, so you can write it like this, x into x. Now what you have to do, you can also do it with p square. You can write x square comma p into p. It is your choice. I have chosen x y because it will give me a simpler view of this. See, x which is on your this side, this x, it can be come it with left hand side, this, and x comma p square plus x comma p square and this x on right hand side here. Okay, so now x, this x is same here x, and x comma p square, I have got the value of x comma pi square. I can write it here that if x comma p n, it is equal to NIH p. This is the general formula. It is the general formula. So you can write with this help of with this 2IH p, h cut p, and similarly x comma p square is 2IH p, and this x is this x. Okay, this x is this x. So you can write 2IH back, you can take common, and xp plus px. Now you have to remember this, that here in quantum mechanics xp is not equal to px. It is the operator. It is in operator form. It is generally in classical mechanics what you can do, that xp plus px you can write 2x p or 2px, but in quantum mechanics it is an operator and the order matter here. Xp is not equal to px. Xp is something different and px is something different. Here orders matters a lot. So you can write this, that order matters a lot. So you can solve it and you will get the final answer, that is this final answer 2IH cut xp plus px. Okay, so this is your final answer. In next question, if we go next, you can also try with it like something you can try it with x cube p cube. You can try it with this x cube p cube. It is a bit trickier, but you can apply the basics and you will get the answer. Okay, so now I will talk about the second question. In second question, it is the operator is given. Okay, So d upon dx minus x, d upon dx plus x. In first this in these type of sums or not, I will say if you if you're learning quantum mechanics, then the basic concept of quantum mechanics is that operator does not have any meaning. Operator does not have any meaning of its own. It has importance when we operate on a wave function. So this is an operator and this is a wave function. Okay, so operator, this is a wave function and this is your operator and this is your operator. So when we will operate, you will solve, and you have to remember one thing here, like when you will solve this, in this you will have to apply chain rule. In this you will have to apply chain rule. In this you will have to apply chain rule. Okay, so when you will apply chain rule, this will cut with this will cancel each other, and you will left with the answer, this answer. So it is very simple. So you will get the answer. And basically what we are doing here, if technically you will speak this psi, and when psi will I take common from here with last step, when I will take common psi from here and this psi, they cannot cancel each other technically. This psi does not mean they will cancel each other, but what we have done, we have equate these two equations. We have equated these two equations and we get d square upon dx square minus x square plus 1, and this is your final answer. Okay, so this is your final answer. So now I will move to next question. So next question is consider a quantum mechanical system with three linear operators, a operator comma b operator and c operator, which are related is this: a operator, b operator minus c operator is equal to identity operator, and if a is equal to d upon dx and b is equal to x operator, then c must be. So we have to calculate c from here, and we have given the value of a and b. Okay, so this is also very simple. What you have to do is you have to put the values of a operator, d by dx, a operator here. This is your d a operator is given as d by dx x minus c. So you have put the value of here a operator, and this is the value of b. So this is the value of b, and minus c is equal to I operator. So when you will solve, d by dx minus I is equal to c, and you will take a, b on one side and c on other side, then you will easily get. Here also you have to apply chain rule. So here you have also applied the chain rule of differentiation. So you will get automatically the answer cx into d by dx. Okay, so now question number 4. Question number 4 says the wave function of a free particle in one dimension is given by psi x is equal to a sin x plus b sin 3x. Then psi x is an eigenstate of, so you have to calculate the eigenstate, that is a position operator, the Hamiltonian, the momentum operator, and the parity operator. Basically what you have to do is to identify which operator is this. So basically in this sum you have to this is hit and trial method. You have to, or you can take an educated guess after practicing many sums, or after practicing lot of problems. You will ultimately try to guess an educated guess, like see, choose option D. Okay, like I assume that it is D. So when you will choose D, so I have told in my in my previous video also, that is even and even function and odd function. So when you will operator parity operator on psi x, so and when you will change x to minus x, so if it gives psi x, there's an even function, and if it is given minus psi x, then it is odd function. Okay, so if psi minus x, I put the sine minus x and sine minus 3x, so sine of minus theta is equal to sine of theta. So sorry, minus sine theta. Sine minus sine theta. Okay, so this is minus sine theta. So it is a parity operator. Okay, because parity operator has the property that it changes when you apply x to minus x. So if it give even function or odd function, so this is the property of your parity operator. So we can easily identify that it is parity operator. Okay, so now if we will do if second question, we will move up to question number 5th. Question number 5th will do. So the quantum state sine x, and then there is an spin up exponential I phi cos spin down. So where your spin up and spin down, when you take a scalar product, it becomes 0, and xy are real orthogonal. So you have to choose that. You have to actually in this question, actually you have to choose from these 4 options that which wave function we will take, and it will become orthogonal to the given function. Okay, so actually what we have to do is to show that your psi phi is equal to 0. This you have to show. So now I will move. So okay, psi I have written it in ket form, sine x, and phi also in ket. So by taking a scalar product, psi will become from ket to bra, and phi will remain phi in ket, and the scalar product will be equal to 0 because of orthogonality condition. So this is an orthogonality condition. This is an orthogonality condition. So now what you have to do, you have to change psi into your bra, and phi will remain into ket. Okay, so when you will solve that, we will know that if from the properties that phi is equal to 1 and psi phi is equal to 0. This is normalization condition, and this is your orthogonal. So from this condition you can solve this easily, and you will get this. And see, basically when you will operate, you will remain with these 2, because this is given in question. This is given in question. So what you will be there with, you will be there with this. So up means plus, and down means minus. So minus become plus, and they will cancel each other. They will cancel each other, and you will get 0. Okay, so option C is right. Option C is this. So option C is right, and that means you have to choose option C to satisfy the given orthogonality condition. Okay, so we will go to our sixth question. In sixth question, the state psi of a quantum mechanical system, we have given a state psi and the operator is also given. And see, basically in this question it is asking that if we now a measurement of variable is made on the system in the state psi, the probability that the result will be +1 is. So basically you can see this question. Basically before starting this question I have to clear some basic concepts, so we can do some basic concepts again. I want to state that, like, if you operate an operator on a wave function, you will get an eigenvalue giving the same, and this is called eigenstate, and this is called eigenvalue, and this is called eigenvalue. So basically I want to state one more theorem, that is, see, this is very important theorem in quantum mechanics. This is actually, you have to see this, that like psi, I've chosen the psi, it is a superposition of many plane waves or an superposition of waves. So you can write it in this form: c1 phi1 plus c2 phi2 plus c3 phi3 c4 phi4 up to cn phi n. So basically it is an eigenstate, so it is a superposition of many waves, and when we do a measurement, so it will give the one of the results, and again it can give any it does not mean that if in first measurement you will get phi 1, then other measurement you will also get phi 2, and it can be phi 2 phi 3, we don't know, it depends on, it is all on probability. So suppose if I get phi 1, the corresponding c1 is your constant, and the probability, this will give you the probability, this mod of the c1 c2 square mod of c3 mod of c4, given the corresponding probability of this particular eigenstate. I repeat that the c1 square, this mod of c1 square mod of c2 square, okay, mod of c3 square, this will give the probability. This will be the probability of corresponding eigenstate. Okay, so basically it should also follow that c1 square plus c2 mod square plus c3 mod square up to cn mod square should be equal to 1, normalized. It should be normalized. It should be normalized. Okay, so basically it should be normalized, and this is one theorem, and this is also theorem. Okay, so basically this concept I want to clear. So I hope this will give you a clear picture of the basic concepts that we will use in this particular problem, or on the further and future problems we will encounter. So what I have done, see, read once more. It is asking the probability that the result will be plus 1. What is this plus 1? Plus 1 is the eigenvalue. And I want to make clear once again that the eigenvalue, eigenvalue and this C1 are different things. Okay, don't confuse it with eigenvalue. Okay, these are two different things. Okay, so this is the eigenvalue. We have to find the probability of the result getting plus 1. So how can we find the probability? First we should note the corresponding eigenvector to plus 1. What is the corresponding eigenvector to plus 1? Only then we can find the probability. What I have said, how the probability can be found. Probability can be found by mod of C1 square, mod of C2 square, mod of C3 square. So how will this come? This will come when you will do the corresponding calculate the corresponding eigenvector to plus 1. Okay, once you will calculate the corresponding eigenvector to plus 1, there is another step that I will discuss in few minutes. Then you can easily find the probability of this of plus 1. So basically you have to understand the concept that whenever you have given the probability that you have to find the probability of this result plus 1 plus 2 or anything, that is will be the eigenvalue. You have to find the eigenvector, corresponding eigenvector to this, and then you will apply one formula that I will discuss in few minutes, and you can find the probability. Okay, so first we will, what our first step is corresponding to given eigenvalue. Okay, so you have to find the first step is to find the eigenvector corresponding to given eigenvalue. So we know all the we know how to find the eigenvector, that is by ax is equal to lambda x. Okay, so this is the theorem, so you will find easily. So after finding that this is the eigenvector, I have to normalize it. You should keep this point in mind that any eigenvector you find, you have to normalize it. So how will you normalize it? So this is the normalization condition. This is the normalization condition. Okay, so you can find this by normalizing we get 1 by root 2. Okay, you can, what you can do is 0 1 minus 1 in you can write this, and you can write this, and you can normalize it. You will get 1 by root 2. You will get 1 by root 2, and you will put this 1 by root 2 here, so you can get the corresponding eigenvector. Okay, now so probability, this is the important formula to calculate so you can calculate probability by this. Actually this is the can show you how to calculate C. Like I have told you that to find the probability you should the mod of C square. So how to find the C? So that is and that C1 C2. How you will find this? You can find this psi is equal to C1 phi 1 . So C1 is equal to phi 1 psi. C2 is equal to phi 2 psi, and C3 is equal to phi 3 psi, and so on. So probability is Cn square. Okay, so you can easily find the probability from you can equate this and take the square, and you will get 1 by 4. Okay, so in this video I will put up to here only, and in later videos I will discuss on some more questions, and next video I will discuss about mainly about harmonic oscillator and uncertainty principle. So next video is very important to understand these two concepts, so you should stay tuned, and thank you very much.